Right. We are going to go do number 21. This is similar to a future one we'll do, number 23, but we're going to go ahead and use some similar tactics to merge two sorted lists, two sorted linked lists. So you are given the heads of two sorted linked lists, 1 and 2. Merge the two lists into one sorted list. The list should be made by splicing together the nodes of the first two lists. Return the head of the merged linked list. So input will be two linked lists, and we're supposed to merge it into one. If they're empty lists, we'll return an empty list. If there's one empty list and one not, you'll just return the smallest of the list that has items in it. The number of nodes in both lists is in range 0 to 50. And then the values will be from -100 to 100. And then both lists 1 and 2 are sorted in non-decreasing order. So what we will do is we're going to compare the heads of nodes, the head nodes of list 1 and 2. Whichever smaller, we'll attach it to our merged list and then move forward. And then we'll just go ahead and repeat that until the list runs out. And then we'll just attach the end once it's at the end. So what we'll do is we'll probably initialize a dummy head, and then that will be our eventual merged list. So we'll move forward with this. So I'll initialize a dummy head by creating a new node. So new list node, just put 0. And then I'm going to make it easy to read, and then just put current is equal to dummy head. So we're going to do a while loop that essentially goes through the list, both lists, until they're completely gone. And we'll make them go away as we move through each node in each list. So while list 1 excuse me, is not equal to null, oops, put a space, null, or, oops, not or, and list 2 is not equal to null. We'll go forward and put a couple conditions. So essentially, this is just saying once you hit a null in both of them, you're done, and you'll move out of the while loop. So if list 1 dot value is less than or equal to list 2 dot value, just a comparison of the second list's value, we'll enter in, and then we'll set the current dot next, which is this piece here. Remember we made a head earlier. It's kind of be like our end list, I guess you could say, if you want to think of it that way. And then we'll just set that to list 1, since list 1 will be less than list 2. And then we'll move the list 1 node forward, list 1 dot next. If that is not satisfied, then we will do a current dot next equals list 2, and then move list 2 forward. So that takes care of moving forward. And then what we'll do is we'll just say current equals current dot next to move that forward. Once we're out of this loop, we'll go ahead and add the last piece of whichever list is left that hasn't already been attached to this dummy head, or what otherwise is the current. So there's one left after we go through each one of those lists. So if it's list 1, oops, not equal to null. Then we'll just set current.next equal to that list one. Otherwise, we'll just set it to list two. But I'm going to do an explicit conditional statement here. Current.next equal to list two. And then all we got to do, since we built that whole current piece, is we will return dummy.head.next. And then that should return that full list, or the head of that list, I guess. So let's go see if it runs. Perfect. So we get two lists, they merge them together, and so it's expected. So if we submit it, we get pretty good runtime. So this is a pretty good implementation of this. It's going to be, since there's two lists and they both have to be run through and they may be of different sizes, what this is a O of n plus m, which essentially means this first list would be n elements and then this one would be m elements because they could be different. So O of n plus m.